boys and girls, happy Monday. Today we're going to learn about patterns in multiplication and addition. So your I can statement is, I can find and explain patterns in addition and multiplication using properties of operations. Don't let that intimidate you. It's not so hard. Before we continue on with the lesson, we need to review some vocabulary. Factor, those are the two numbers that you multiply in order to get the product. Pattern is just seeing a relationship between numbers. Even, remember, even Steven, oddball out. Even numbers pair up, odd numbers have a leftover. And the commutative property. That would be when you switch the two factors. You still get the same product, even though it's written in a different order. Okay, now that we've reviewed, let's get started on some problems. For this lesson, you might want to have a multiplication table available. Let me show you how you can find that. You can use the one that's in the lesson plan, or you can go to ClassLink, go to McGraw-Hill, click on your student workbook, and we are going to be in Chapter 6. You'll need this for your activity today. Chapter 6, Lesson 1. When you're here, you will see the multiplication table. Oops, clicked on the wrong one. There we go. You will see the multiplication table right there. So you can use this to help you on today's work and in the future. And yes, the Teenage Mutant Ninja Turtles wanted to help you out today too. Okay, let's use our multiplication table to solve our first equation. We have 2 times 9. So I'm going to come over here to the 2's row, and I'm going to color the whole row green. And then I'm going to come up to the 9's column, and I'm going to color the 9's column down until it meets my green. Hey, where did it meet? That's right, the number 18. And that is my product. 2 times 9 is 18. Now I could also flip it and use the commutative property and do 9 times 2 at 18. Okay, let's try another one. Let's do 3 times 7. I'm going to come over from 3, and this is where if you have two hands, it really helps. So use your left hand and push over, and use your right hand and pull down. And what do you get? A 21. That's right. And 3 times 7 equals 21. This is a pretty handy table, isn't it? I thought you'd like it. Now we're going to look at other ways we can use this multiplication table. We're going to use it to look at patterns. All right. We're going to look at the patterns that we see when we do multiples of a number. Multiples of a number are just the products of when you multiply the same number times a lot of different numbers. So let's do the number 2. I have 2 times 0, which is 0. 2 times 1, and I get 2. And 4. You guys are really familiar with this one, aren't you? Go ahead, you can keep counting. I'll eventually get there. Good job. All right, when we look at this row, what are some things you notice? One of the things I notice is that it's a pattern. 0, 2, 4, 6, 8, and then when I look in the ones place, I see another 0, and then another 2, and a 4, and a 6, and an 8, and it goes back to 0, 2, 4. So I can predict that the next number in the pattern would have a 6, and it keeps on going. Something else I notice about this pattern is that all of these numbers are even. Did you notice that? I bet you did. Now let's take a closer look. When I have 2, which is an even number, multiplied by 0, which is an even number, I get an even number. When I have the even number 2, multiplied by the odd number, I got an even number. When I have an even number times an even number, I get an even number. 2 is even times 3, which is odd, and I still get even. So I'm going to write this hypothesis. Let me grab a dry erase marker. I'm going to say I notice that even times even equals even. But when I have an even number 2 times the odd number, I still get an even number. Are you agreeing with me on that? I wonder if it's different if we start with an odd number. Let's try it. Let's use the number 3. 3 is odd times an even, and I get an even. Odd 3 times odd 1 equals odd 3. Odd 3 times even 2 gives me even 6. Odd 3 times odd 3 gives me odd 9. Odd 3 times even 4 is 12, which is even. Odd 3 times odd 5 gives me odd 15. Guys, are you seeing this? Every time I multiply an odd number times an odd number, I get an odd number. So I'm going to write that up here. Odd times odd gives me odd. So even times even equals even. An even number times an odd number is an even number. But odd times odd will give me odd. Practice that a little more. Do some discovering on your own and see if it still holds true. All right, now it's time for your activity. You're going to come back here to your McGraw-Hill Math. You should be in Chapter 6, Lesson 1. Click on the green ebook. This will take you to page 295. This is a great page to review, but you don't have to do this as part of your activity. You do, however, need to work on page 296 and 297. This page will be asking you to do things very similar to what we just did, recognizing the pattern, such as in the 2's row, you always see 0, 2, 4, 6, 8, and it keeps repeating. We also saw that all the numbers in the 2's row were even numbers. However, when we looked at the 3's row, we saw that some numbers were odd, but other numbers were even. Thanks for watching, and I hope you have a great Cinco de Mayo tomorrow. Maybe you could even do some multiplication and division with your chips and salsa. Have a great one.